The nth term of an AP cannot be n square plus 1. Justify your answer. So the question has to do with something like this. What they're telling is, see, this particular expression, like an is equal to a plus n minus 1. This particular expression is a general expression for an AP, right? What they're telling is this particular expression n square plus 1 is not a general expression for any AP. Okay, that's the question. If you're not able to understand that, let me write the answer. It will be simpler. Just a second. I had to nothing. Okay, let me start off. Okay, let me start off, then it will be easy to explain. First thing is, let's consider an, which is equal to n square plus 1. Okay, let's consider this to be nan, that is to represent nth term of an AP. Right, so we can represent a1, which is n square 1 square plus 1. All we are doing is substituting in place of n 1. Okay, and then we have a2, which is 2 square plus 1. So this would be 2 square plus 1 would be 5. Then we have a3, which is 3 square plus 1, and this would be equal to what, guys? 9 and 10. Okay, so this is what we have to do. First we will find a1, a2, a3. Doesn't matter whatever the expression is, just substitute in place of n, substitute 1, 2, 3, 4, get 3 is enough, 1, 2, 3, and then find the difference, a2 minus a1. So this would be equal to 5 minus 2, which is equal to 3. Then we have a3 minus a2, which is equal to 10 minus 5, which is equal to 5. And then on to telling, what is that we're looking at? The whole funda behind an AP is this, that the difference between any two terms has to be fixed. Is this fixed? It's not. And thus we have as a3 minus a2 is not equal to a2 minus a1, right? What can we tell? This implies, because of this we have the nth term does not represent nth term of an AP. That's it. Understood? So again, please see to that you understand the concept. So I would like to put a general word for this particular section of question. Please understand them. Just don't watch the answers. If you watch the answer, you will know how to write the answer, but you won't understand the basic idea behind it. Okay. See, this sequence, this expression represents a sequence. It follows a particular rule, and the rule being that we can get the next number by adding or multiplying with something. You know, there is a pattern. Okay. So there is a pattern, and it's basically multiply the square of the position plus add 1 to it. That's the pattern. But the point is, this is not in AP. Why is it not in AP? Because AP is defined in that way. So what is the definition of an AP then? To define AP, it's to tell key you find the next term by adding a value to the previous term, and that value is fixed throughout the series. That's an AP, right? That's why we have a plus d, a plus 2d. If it's not able to follow that rule, that is the difference between any two consecutive terms turns out to be different, it's not an AP, as simple as that. Okay, so that's your general idea of this topic, and it uses that very well. So there are a set of questions which uses this idea, and they are the hard ones. You know, many people, most of the kids find this to be the hardest part in the arithmetic progression questions. So please understand, just don't watch.